Again, this lectures cover the hypothesis testing with two samples, and we are going to use the z-test. In our next lectures, we are going to use the t-test. So first, our main objective here is to determine whether two samples are independent or dependent. Also, we are going to perform two sample z-tests for the difference between two means. That's mu1 and mu2 using a large independent sample. So using large independent sample means our sample size should be 30 or more. Now, first thing, we are going to compare two parameters from two populations. And as we said, the two sample hypothesis testing, we have the independent samples and also we have dependent samples. Normally, independent samples means the two samples may come from different population and also the size may be different. Now, dependent samples, which also called the paired or matched samples, the two samples must come from the same population and also the size might be the same. That's why we use the term pair. We compare both samples. So that's the diagram given to us here. So we have independent sample here and we can see that the sizes are different. So we cannot pair sample 1 and 2. By dependent sample, we can see the two samples are the same size and we can pair them. Now, let's do some few examples here, how to classify the pair of samples as independent or dependent. So first example given to a resting heart rate of 35 individuals before drinking coffee. And the second sample is the resting heart rate of the same individuals after drinking 2 cups of coffee. So here we can see that the keyword is that the 35 individuals resting heart sample before drinking coffee and also resting heart rate of the same individuals after they drink 2 cups of coffee. Now the keyword is that they are the same and also the size is the same. So this is dependent sample. So here we say the samples can be paired with respect to each other. So it's a dependent sample. Now, the next example, we have a test score for 35 statistic students. Then we have test score for 42 biology. So now we have 2 different individuals. These are biology students who do not study statistics. So this will be, again, a dependent sample. Also, we can see the sizes are different, so we cannot pair it. So this is independent sample. Not possible to form a pairing between the members of the sample. Why? Because the sample size are different. Now, anytime we are doing hypothesis testing, the first thing we start with is stating the null hypothesis testing and also the alternative. Normally, the null hypothesis testing, sometimes we may use the term the claim. So here we say a start hypothesis that usually states there is no difference between the parameters of 2 populations. And always contain the following symbols: less than, equal, equal, or greater than or equal. Then alternative hypothesis always will go against null hypothesis. So if null hypothesis is less than or equal, then alternative hypothesis will be greater. If null hypothesis is equal, then alternative will be not equal. If null hypothesis is greater than or equal, then alternative hypothesis will be less. So these are all the possible examples again. We have equal for null hypothesis, alternative will be not equal for both. Now, one thing also we should know is that 3 conditions are always necessary to perform a z-test for the difference between 2 population means. First, we say the samples must be randomly selected. Then secondly, the samples must be independent. And then each sample size must have at least 30. Or if not, then each population must have a normal distribution with a known standard deviation. So if these requirements are met, then we say that the sample distribution for the difference of the sample means is a normal distribution with the following. So we have the difference of the population mean for the. Then also the standard error formula will be the square root of the variance of the first sample divided by the size of the first sample plus the variance of the second sample divided by the sample size, the second sample size. Then we know the sample distribution. Again, we have a normal distribution here. Now, let's see the test statistics formula. So the test statistics is the difference of the sample mean. So to find the standard test statistics, it will be Z equal to the difference of the two sample mean minus the difference of the two population mean divided by, again, our standard error. So when the sample size are large, we always can use S1, S2. S1, S2 will be the standard deviation for the sample instead of the population, in place of the population standard deviation. Now, if the samples are not large, then you can still use two sample z-tests, provided the populations are, again, normally distributed, and also the population standard deviation are known. So let's put this in words step by step. So the first thing we do, again, we state the CRIM mathematically, and also identify the null and also the alternative hypothesis, which means we state the HO and HA. Then secondly, we have to specify the level of significance. That will be our alpha. Most of the time by default is 0.05. Then we need to sketch the sample distribution. Then we are going to use the critical values. Now, how do we determine the critical values? We use the table 4 in our textbook, which is Appendix B, to find the critical value. Then, if we know the critical value and also we know the test statistics, we can find the rejection region. So we find the test statistics, and then we make a decision to reject or fail to reject the null hypothesis. So normally, if the Z is in the rejection region, then we have to reject HO. Otherwise, we fail to reject HO. Then next, we have to interpret the decision in the context of original CRIM. Now, let's see an example. So here we see a consumer education organization claims that there is a difference in the mean credit card debt of males and also females in the United States. Now, the result of a random survey of 200 individuals from each group are shown below. The two samples are independent. Do the results support the organization claim? Here we are assuming alpha is 0.05, or the level of significance. So based on the data, they gave us the females section and also the male. The sample mean, the sample standard deviation, the sample size. Same thing applies to the males also. So next thing we need to do, which is our first step, is to state the HO and the HA. Now, based on the question, we can state that they are equal or they are not equal, which means there's no difference. Always we say the HO, no difference. HA, we say there's a difference. Alpha is given to us to be 0.05, and the sample size also is given to us. So with this, we can be able to find, again, the critical value. So we use our table to find it, and that's the value, again, based on the alpha is 0.05. So that's why we have an equal, so two sides. So that's why we have 0.025, 0.025. Total together will be, again, 0.05. Now we know from the table, the Z will give us 1.96. So negative side and the positive side. So now we almost have all the value to find the Z, or the test statistics. So we have the mean for both, which is given to us. Let's go back. So we have the mean for the female and also the mean for the male. Also, we have the standard deviation for each. So we can be able to find the test statistics. So we plug in our values, and then we find the Z value to be negative 1.03. Now we can see negative 1.03 will be in the bruised section. So this means we cannot reject HO. And positive, also the same thing. negative 1.03 will be failed to reject. Blue section is to reject. So we are in the region of fail to reject, which is the brown area. As we can see, negative 1.96, negative 1.03 will be right after negative 1.96. So we see at 5% level of significance, which was given to us, there is not enough evidence to support the organization claim that there's a difference in the mean credit card debt of the males and females. So here again, in summary, we learn how to determine whether two samples are independent or dependent. And we perform a two-sample z-test for the difference between two means using large independent. Again, the goal here, the steps, first we state our HO and HA based on the question given to us. Alpha is given to us. We also know the sample size. So if we know the alpha and sample size, we can be able to find the test statistics. First, also, we use the table, the standard number table, to define again the critical value, which in this case, 0.05, we are is equal two sides. So we have 0.025, 0.024 on the right and left. And finding it, we get negative 1.96. And then we do our Z statistics, we get negative 1.03. Negative 1.03 fall inside fail to reject area, which is the brown area. So that's the conclusion. Again, wish everybody the best and thank you.